Hello student, today I will continue the lesson. There's a 5.5 from 4. Okay, there's a diffraction of the wave. Okay, let's see. This one is a short of the topics. We just discussed about the diffraction. Okay, let's see what's a diffraction. Okay, first one, diffraction, there's a one of the spreading and also bending. You can say the spread. You also can say the bending of the wave as they pass through the obstacle, or you can say opening. Obstacle means the something there's a blocking. Okay, opening means this one situation. This one diagram they show about the opening. Okay, now the wave front of the sea water, they changes from the plain water frame in the region A. Okay, let's see the region A. Region A is a deep area. So the wave front that will changes. Okay, from starting you see the wave front should be the bigger because this one is a deep area. Okay, to circular wave front in the region B. So can you see the shape? When it just go in the small opening, the shape becomes circular shape. Okay, you can see the clear about the wave circular. So this one will show there's a sea wave that spread out while they're propagating through the gap in the embankment. So this one is an example for the diffraction. So the diffraction situation, that means they must go through the small gap or they hit the obstacle. So finally the wave will be change another shape. Okay, we go and see the following. Okay, we introduce about the water wave first. Okay, water wave diffraction means the amount of the wave that bends depends on the size of the obstacle and also the opening. So you want it to bend more, or you can say diffracted more, you need to adjust about the size of the obstacle and also the opening. So this one need to bend. Okay, now you see the diagram. This one is a river tank. They do this one experiment by using the river tank because there's a water wave. So when the diffraction of the wave happen, so this one is an example how to create diffraction. We're using the two barrier. Okay, the wave is produced from the motor. Okay, first when starting they produce is a plane wave. Okay, after they pass through the gap, this one we call gap. So this situation, they will change about the direction and also they change about the shape. So this one is a diffraction phenomena. Okay, let's see the example here. Here is a small optical. Okay, so small optical means something there's a blocking. Okay, this one is a small opening. Okay, how we know there's a small or there's a big? Okay, we compare by wavelength. So if this one is a opening, this one is a lambda. If the opening A smaller than the lambda, means you are small opening. If the A here is wider, means there is a bigger than the lambda, we call it there's a bigger opening. So we take the lambda as a standard to compare. Okay, so this one is the first one. There's an obstacle to block. Okay, when starting you find it there's a plane wave. Okay, when I hit the obstacle, you find it that bend a little bit. Okay, at the top and also at the end. So from here the center there's a don't have any wave. So if I put a small stone at the middle, actually there's a no effect because there's a don't have any wave to affect it. Okay, then this one is an opening. When starting is a plane. When I go through the opening, that means here, this part, upper part and lower part, the water or you say the wave cannot go through. Okay, so they just can go in through this one small opening. When they just go through the opening, then we call it they spread out. Okay, they spread out. Okay, when they spread out, we depend the anchor. If the anchor bigger to spread, mean there's a diffracted more. Okay, if the anchor you spread a little bit, mean you are diffracted less. So this one, they change about circle shape. Okay, we also can compare the circle. If the circle you are more curved, means the diffracted is high. If the circular is a less curved, that one is a less diffraction. Okay, we go and see the next one. Okay, the next one we see what should be changes after diffracted. Okay, first one, do not change. Lambda is never change. Means before that and after that diffracted, the lambda should be the same. Okay, frequency also never change because frequency they're from the same motor from the river tank. So the frequency should be the same. The speed of the wave also never same. never change because there's the same medium. Both also is a liquid water. Okay, what should be changes? First one is the amplitude decreases. Amplitude, we can say there's an energy. Because they pass through the opening, they spread out, means the energy loss. So if the energy loss, we can say the amplitude loss also. So from here, we can say amplitude decreases. Okay, number 2, the direction propagation. Okay, when starting, it's a straight line. So after they go through opening, you find it they're wider. They open wider, means the direction changes. And the last one should be the pattern changes. When starting, it's a straight line. After past the opening, they become curved line. Or you can say this one is a circular shape. Okay, now we're going to see the factor that will influence the effect of the diffraction. Okay, from here we got 2 factors. First one is the size. Size of the gap, size of the obstacle. Okay, if they become smaller, the diffraction will become better. Better means bigger, or you can say clear, or you can also say about the more circular if the size becomes smaller. Okay, now another one should be the wavelength. Okay, wavelength is large enough. If they're large enough, diffraction is more better. Okay, we see the situation. We go through the gap first, the opening. If the opening bigger than lambda, okay, means wider. Okay, the opening too wider. So this one is an example from the river tank. So this one we call it the gap, or you say the opening. This one opening wide enough, bigger than the lambda. So they find it, the spread become less. Or you can say diffraction become less. Circular, you also cannot see clear. Okay, you see the bend a little bit at the end only. The rest is a straight line. So this one we say the less diffracted. So from here, this one is a diagram we draw. If you want to draw. So drawing means you need to show a little bit bend, okay, at the end. So we show the after diffract. So this one still not curved. We can say about less curved because they're not circular. They just bend a little bit only. Then the opening, the direction you spread out, okay, also less. Okay, you cannot open wider. You just open small angle only. So this one is when the wider slit, they produce less diffraction. Okay, then we go to second one. Okay, second one means the gap is smaller. Okay, you see the size of the gap. Now it's less than lambda. Okay, less than lambda means you are very small. Okay, when very small, you can see it, they become circular already. The shape becomes circular and the direction spread out also wider. So this one from the river tank. This one is drawing. Okay, when starting is a straight line. When I just go through the opening, you find it, they become circular. Okay, then after that, the arrow also open wider. So make sure the lambda before and after should be the same. Okay, from here, how to explain the diffraction result? They're more circular after diffracted. So this one normally they come with the question is a comparison. So comparison, you say one is a less circular, another one is a more circular. Okay, then we see some of the diagram. Okay, and you can say about the experiment sample for the diffraction. Okay, from the different gap. Okay, let's see the first one. The gap is very small. Okay, you can see the circular is more. Okay, the circular is more. After that, they open wider. Okay, then we go to the second one, this one. Okay, when I open the gap wider a little bit, you can observe about the shape and observe about the spreading angle. Okay, they're still circular but less. Okay, this one is an open wider area. Okay, so we compare just now again. Okay, just now you can see it, they open more wider. Okay, this one open more wider. Okay, this one is more circular. Okay, then we go to the last one. The last one when the gap is very large. Okay, can you see circular? You just can see the circular at the side only. Okay, end of the shape. Okay, and also they open too large already. Open too, not too large, they open less. Can you see the wider the arrow, when they spread out, they become less. Okay, from the first one, okay, you find it, there's a wider area they go to spread. Okay, so this one is a what different for the tree diagram about the different size of the gap. Okay, now we're going to see the obstacle, the first one. This one obstacle is a small obstacle. So when the wave just go through the obstacle, you find it the center should be empty. Okay, empty means nothing to see lah. Okay, until 1, 2, 3. Number 3 already they join back about the wave pattern. So means this one still clear. We can say there's a clear. We can say more obvious. Diffracted more, or you say diffracted more obvious, because they just blur a little bit from the starting part. Okay, if I make the obstacle become larger, okay, so you can find it, the wave, they take longer time to join back. So this all empty part, we call it there's a blur part. There's a not clear. So we call it there's a less diffracted. You can say there's a less obvious. Okay, make sure when you draw bend a little bit at the end, then straight. Okay, and then you bend a little bit, finally they will join back. So if they take long time to join back, means this one is not clear. There's a less obvious. So from here, smaller obstacle is better. Okay, because there's a less more diffracted. Then how about the bigger obstacle? There's a less obvious and also less diffracted. Okay, so this one is a result from the obstacle. Just now is a opening. Okay, so now we go to the second factor. There's a wavelength. Okay, the second factor is talking about wavelength is bigger, diffracted is more. So we're going to see, is it the correct for the hypothesis? Okay, when starting, I'm using the wavelength, small wavelength. Can you see the wavelength closer? Okay, when the wavelength is closer means the wavelength becomes smaller. So can you see the diffraction? Open, wider or less? Should be less, because if open wider means you go more outside. This one is less. When you open less, that means you find it you cannot draw the circular, because you less opening, your anchor becomes smaller, circular cannot draw. So from here you can see the after diffracted, there's still straight line. Okay, bend a little bit at the end. So this one is a drawing. So that spread, less anchor. After that, they bend a little bit at the end, center still straight line. So this one we call less curve, or you say less circular, when the wavelength becomes smaller. Okay, now we go to the large wavelength. That means the wavelength become longer. So if you compare just now, this one wavelength is big enough. Okay, when the wavelength is big enough, can you see the open wider? When the open wider means the anchor here is a bigger, so they can show about circular shape. This one circular shape is more clear. So from here, this one is a drawing. So when wider of the gap is a constant, we wider about the wavelength. If your wavelength become longer, you find it they spread wider and also bend circular more. Okay, so from here, if comparison, you answer after diffracted, then more circular. So this one is a wavelength affected the diffraction. Okay, longer wavelength, diffraction is more. Okay, this one is some of the result from the experiment for the longer wavelength and shorter wavelength. Okay, let's see the longer first. Okay, the longer wavelength, you find it, the anchor open. Okay, I repeat. Okay, the anchor open is here. So you can find it, they are more circular. Okay, more circular. Okay, if I'm using the short wavelength, okay, the open less. Okay, the spread out the anchor less and also less circular. So I both and on together. Okay, you can see what's the difference. So this one is more circular, this one is less circular. Okay, and also the open anchor smaller, this one is open wider. When they open wider, they sure become more circular. Okay, so this one's a two phenomena that will affected for the diffraction. First is a size of the gap, or you say size of the obstacle. Another one should be the wavelength. Okay, now we need to go to the another type of the wave. Okay, we need to go is a light wave. Light wave also the same thing. We go and see the diffraction. Okay, the diffraction of the light wave, they occur when the light wave, they pass through a small slit. Okay, this one we call small slit. Okay, one of the very small hole, or you can say one of the slit, the longer one. After that, the laser pen will pass through. Okay, after that, the small slit, or you can say the small pinhole. Pinhole means a circle. So we start with the slit first. Okay, the wider the middle bright fringe, mean the center one, they show that the light wave. Okay, the center one is a light wave to go and also diffract. When they pass through this slit, they will diffracted. Diffracted, after that they open wider, is it? When they open wider, that means the screen will full of the light, but the light, they got different color. Okay, normally we didn't say color, we say bright and dark, the fringes. So if I using purple color laser, means this one is a result. Okay, then we diffracted after pass through a small slit. So this one, center one, sure is a wider one, because your light goes straight. Okay, then the rest should be dark and also bright, dark and also bright. So you can see here, this one, first one, they pass in a small slit. Okay, the slit become bigger or smaller. Then this one continue for the middle, and the last one, this one, the slit is wider. So you can see what's the difference. Okay, this one, the fringes will become bigger. This one, the fringes become middle. This one, the fringes become smaller. Okay, we continue to see the next one. Okay, this one is an example. When you see the diagram center become wider, this one sure is a phenomenon for the diffraction. Then the rest, they are not same size. Okay, every fringes, the size, the wider, that's not the same. You cannot say the first one and the second one should be the same. No, maybe some bigger, some smaller. They're not consistent. I just know the center sure is a bright fringes. Okay, this one is pass through the pinhole. Okay, if you make one circle, it's an empty, very small, you let the light to pass, then you see the diagram should be like this. The center sure is a bright fringes also. Okay, this one is an example. Pass through the single slit. Okay, center become clear, then the rest become smaller and also closer. Then this one is a pinhole result. Okay, let's see some of the result from the example. Diffraction pattern through the single slit. Okay, we make the slit become wider and wider. You see what's the difference? Okay, first one, this one. Okay, I show the first one first. Okay, first one, this one is the slit is smaller. When the slit becomes smaller, you can see the left hand side and right hand side, dark color and also the green color, there's a more clear and also separate, you can see very clear. Okay, now I increase the slit. Okay, now the slit increase a little bit. So you can see the center becomes smaller. Then the side and the side, dark and also bright, they become closer a little bit already. The dark fringes you cannot see very clear. Then the side become blur. Okay, now I keep to increase. Okay, I keep to increase. Then you can see like here, the other side you cannot see already. The another left hand side and right hand side, the green color light become very small. Okay, you cannot observe become clear. So I continue again. Okay, this one totally you cannot see already because I open the slit is more wider and wider. So maybe you can see all is a one light only. Okay, cannot see the other side. So I repeat again from starting. So this one is a smaller slit. You can see very clear. Okay, so I just increasing the slit. So that one is a result. Okay, if you more increasing again, you find it that just one light only. The sides cannot see. Okay, because they cannot focus already. They straightforward go in, they go wide, open wider. Okay, now we go and see the pinhole. Okay, pinhole, just try one of the situation. So this one is a pinhole. They just center become bright, then the rest become less brighter, dark and bright like this only. Okay, this one don't have any changes because I never adjust about the size of the pinhole. Okay, so conclusion from here is when you open the slit become wider, you find it that's not clear about the fringes. They just see the light only. Okay, if I make the fringes become smaller, then you can find clear. Okay, dark and bright fringes is more clear. Okay, last one should be the diffraction of the sound wave. Okay, this one is a listener that stand at the position of the Y. Okay, so that the radio is beyond his vision. They cannot see the radio. Okay, they just be at the corner there. Then after that, the listeners, they're still able to hear the sound of the radio. Okay, although they're just behind the wall. Okay, why? This one is one of the questions they will ask. Why you cannot see but you can listen? So because of the sound of the radio, they spread around the corner of the wall due to the diffraction of the sound. Okay, from here, water, light, and also the sound. Sound is a better in diffraction. Okay, what's the reason? Because the lambda, wavelength of the sound wave is longest compared to the others. So that's a more easy to be diffracted. Okay, if I compare with the light. Okay, so from here, I in two different rooms. In room A, I go to on the light. You in the room B, you sure cannot see the light, is it? Okay, if I at the room A, I on the radio, then you are in the room B, you still can listen. So this one is what's the difference for the diffraction compared to light and also the sound. Okay, because we're not related with the speed, we're related with the wavelength. Okay, so from here, let's see some example diffraction wave in the daily life. Okay, first one, the diffraction of the water wave. They produce a calm. Okay, because after passing through, you find it the amplitude become less, so the energy become less, they become more calm. Okay, the water region, they become more calm. After that, they're suitable for the docking of the shape and also the water recreational activities. So normally they create this one as a jetty lah. Okay, we build a jetty, let all the shape can be parking here. Okay, another one is diffraction of the light in your daily life. Okay, example is a hologram. They're produced by the effect of the diffraction of the light. Okay, they are used as the safety feeders on the bank card, such as a debit and also credit. So this one is an example for the light, diffraction of the light. Okay, and the last one is sound wave. Okay, the infrasonic wave. They're produced by the sorry, this one is okay, we're talking about elephant. They're using the infrasonic wave. They're produced by the elephant. They have the long wavelength. Okay, that means the diffracted is more. So from here, what's the function for this one long wavelength? They want to facilitate long distance. So they travel long distance. That means they can be communicate with the another elephants. So this one is a benefit by using the sound wave for communication between the elephants. Okay, so this one is diffraction. They're just one of the short topics. So hope you understand about this. So next one you should be do the tutorial. I also will be update the tutorial answer here. So from here, thank you for your watching.